Whenever we deal with a simple harmonic oscillator, we have a unique angular frequency, omega, and a unique period of the oscillation, which we normally call capital T. So omega, which is in radians per second, equals 2 pi divided by the period t. And t is in seconds. And the frequency, not to be confused with the angular frequency, is 1 divided by t. This is the number of oscillations per second, which we often also expressed in terms of hertz. Now, whenever we deal with pendulums in which we have a string and a bob, we also deal with tension. And tension, we always write for tension capital T. And so now you have a confusion. You have the T on the one hand for the period of the simple harmonic oscillator, and on the other hand, you have a T for tension. I will therefore use for the period of a simple harmonic oscillation, but only when we're dealing with a pendulum with a string, that means you have tension, I will therefore use for the period then capital P. So in the case that we have a pendulum with a string, I will reserve T for tension, and I will reserve P for periods. So now we're going to have omega, angular frequency, of the pendulum with a string and a bob, will be 2 pi divided by P. Now there are pendulums where there is no string, and then there is no tension, and then of course I will use capital T for the period. For instance, here you have a ruler, and we will be doing problems whereby we swing this ruler as a pendulum. I have it here in a pivot point here, a little hole in the ruler, and I oscillate it back and forth. There is no tension here, and so in that case I will simply use capital T. Now I have to make one confession, and that is, this is my plan. I plan to always use capital P when we're dealing with strings and bobs, but I can't guarantee you that I will really do it always. I may occasionally slip up, and if I do, if I still introduce capital T for period, please do forgive me, but I'll do my best.